So I'm talking to Marc Weber, who is an internet historian here at the Computer History Museum, which is hosting this 50th anniversary celebration of the internet. So Marc, what are some interesting things about the history of the internet that hardly anybody knows?
Well, this you may have gotten from other people, but the basic protocol of the internet, TCP, was created over several days in a hotel room by two young men, Ben Cerf and Bob Kahn. And they just sort of hammered out this spec. And the internet was really born, though. I mean, that would be, if you talk about, with a lot of these things, you can talk about kind of a conception, a birth, and then like growing up.
Now, what was the significance of the TPI protocols? Is that what allows any computer to join the network without needing permission from anyone, as long as it used the right protocols?
But more basic than that, it's just the basic protocols to connect networks to each other. So before TCP and other things like that, you did have networks like the ARPANET, the NPL network, several, there were a number, dozens. The problem was those networks couldn't talk to each other. So TCP was an inter-network. So the name internet comes from either internetworking or interneting, which was a technical term at the time. So it's a network of networks.
Did anyone ever suspect at the time that this would essentially take over the entire world?
Not that particular protocol, except maybe the people directly involved, because certainly there were other efforts to do something like that. But the idea that networks could become as common for consumers as TV was around, but it wasn't, I would say, it was kind of still a science fiction idea at the time. Like Martin Greenberger in 1964, if I'm remembering right, but somewhere around there, wrote a big article in, I think, The Atlantic, talking about like computers of tomorrow, some title like that, where he was predicting home shopping from a terminal, home banking, all the kind of stuff we do today on computers on the internet. But he was working with some of the early pioneers at MIT, with J.C.R. Licklider, who's really the guy that kind of launched what became the ARPANET. So I mean, he was an insider. He was doing a popular article, and you can find it online. It's really worth reading because, he's predicting an awful lot that we do today. So the idea was out there. If you went to, I think it was the World's Fair, they had, booths of tomorrow or something of tomorrow, where they're predicting, again, a lot of these kind of consumer services. But the idea, it was future-y stuff. It's like, the average person didn't necessarily think this is going to come soon and revolutionize my life.
How is this going to grow in the future, and what more can it do that it doesn't already do?
Well, it can do more of the same, but, and I mean, something that I thought of afterward that would have been interesting to say to the group today is, we think that it's all so fast and so effective that you don't need anything more. But everyone talks about, virtual reality or interactive rooms where maybe the walls are covered with monitors, in essence. All of that requires a lot of data. If you ever get, there's Neuralink with Elon Musk, there's Open Water, Mary Lou Jepsen, these ideas of brain-computer interfaces. If any of that stuff pans out, you might need a lot of data. I mean, just virtual reality at high resolution is a lot of data. So, I mean, almost all of the kind of futuristic things people talk about, and obviously generative AI is already using a lot of data and capacity, they all seem to involve moving more bits around faster.
I've heard of biological computers that mimic biology. Is that something that's on the horizon?
Well, I mean, right now, a lot of the discussion is around what computers can do, particularly with AI. What seems to not be in the public conversation as much is biotechnology, which is very much going to be accelerated by, certainly, I mean, they've already solved basically protein folding, how do proteins fold into their shapes with AI. The connection between them, I think, is, can really accelerate biotechnology. So I think it may be a very rich period for both. I mean, AI may not do all the things people hope it will, but in terms of helping with certain kinds of research, including biotech, I think it's clearly going to play a role.
Do all these technologies kind of converge, like information technology, artificial intelligence, biological? Can studying artificial intelligence give us greater insight into our own mind's work?
Well, certainly. I mean, that's one of the original motivations for AI. Both ways. I mean, both computer people look to, I mean, in a way, the digital computer is kind of imitating a very simplified understanding of how brains work. The basic circuits of logic, and or not, there was some inspiration by people that were doing neurobiology research back then. Neural networks take their name from, again, a very simplified model, but somewhat inspired by biology. On the other side, you have people using computers to study the brain and to study neurobiology. So, I mean, it goes both directions.
So I'm wondering if computers could solve some of the problems of the mind, because the stuff between your ears is kind of unknown territory to a very large degree. And we can master electrons and things like that, but measuring the stuff that goes inside, and why do people do some of the bad things they do, or why do they do good things, still pretty much unknown.
Yeah, although, I mean, not necessarily encouraging for the idea that it'll be easy to understand, is already large language models, the generative AI, is very difficult for us to know what goes on inside them. That's the issue of explainability. They produce a result, but you don't know why they're producing it, and you can't easily tweak it to produce a slightly different result. So it's a black box. Yeah. The point is, we've created those systems, and we still don't understand them. So the idea, the brain is very complicated, and we didn't build it. So I'm just saying there's a lot of research ahead, I think, eventually, but that could be a long time.
Where is most of the research effort going now? Is it going on the information technology or the practical applications like AI? I mean, is it market driven? Like wherever there's a market, that's where the resources go?
Well, I mean, more and more you have companies doing research. The sort of publicly funded research that, like a lot of the milestones celebrated by the IEEE, are coming from government money to fund fairly basic research. Or, in the case of Xerox PARC, corporate money, again, though, to fund applied but quite far out research. I've certainly heard from people in the research world that, you're not getting as much general funding for general research. It tends to be more applied and more product driven.
What do you think is the most important thing for people to understand about the internet?
I think the most important thing for them to understand is what you just touched on, that it's hard to control, and that, caveat emptor, let the buyer beware, that you need to learn, and, I try to teach my son, and the school does, how to use the internet responsibly. The same way that my generation learned to, not pay attention maybe to TV ads, you need to become an informed digital citizen. And I think a lot of it is just learning by experience that, the media we grow up with, we learn to use in a way that serves us. But it takes time and experience. And, there's a risk that the medium can change so quickly that becomes hard to keep up with.